Pattern matching is one of the most commonly used language constructs in Scala. The name pattern matching would suggest that it's some kind of sophisticated machine learning algorithm, but in reality, pattern matching is a very powerful form of a switch statement from Java or C or C++. As with many language features in Scala, pattern matches are carefully designed. There is no fall through, so at most one pattern will be matched against. And there are no break statements in Scala. But most importantly, pattern matches can be on a variety of different conditions, on type, value, or on a specific Boolean expression. The sheer range of patterns that can be matched using this construct are the reason for its great popularity. Let's plunge right into a simple demo. Let's check out how pattern matches work. Most folks have encountered switch statements in Java or C# or similar languages, so I'll reiterate for their benefit that pattern matches are really similar conceptually to switch statements in other common languages. Let's start our little example with a value called day of week, and the value assigned to that is Monday. Next up, we have a match expression which will return a message depending on what the day of the week is. If the day of the week is Monday, then our match expression will return the value Manic Monday. If it's Sunday, it will return the message Sleepy Sunday. Let's take a second to familiarize ourselves with the syntax of the match expression. First off is the name of the value to be matched, followed by the match keyword. Then follows an expression block with a bunch of case clauses. Each case clause starts with the keyword case, followed by the pattern to be matched. In this example, both of the patterns to be matched are simply the values, Monday and Sunday respectively. Next up comes the arrow sign, which is the equal to followed by the greater than sign. And then on the right hand side of each of those arrow symbols come the values to be returned in case that particular case clause evaluates to true. Let's see how this plays out in our specific example. The value to be matched is Monday, and so the first of our case clauses will be matched. The right hand side of the first case clause is the string Manic Monday, and so the return value of this match expression as a whole is the string Manic Monday. A few different points worth paying attention to here. Notice how we do not have a break statement at the end of each case clause. That's not required because control does not fall through. As soon as a case clause is encountered which matches the original variable, the expression on the right of the arrow sign will be evaluated, and that will become the return value of the match statement as a whole. Notice also how in this example we only have patterns to match two possible cases. What if the variable that we are seeking to match did not match any of our patterns? Let's say for instance that the value of day of week was Monday with a lowercase m. It would not match either of the patterns Monday or Sunday, uppercase M and uppercase S, and the result would be a scala.match error. As you can see, it's your responsibility as the programmer to make sure that at least one of the patterns does indeed match, or else you need to be prepared to handle the resulting scala.match error. Never fear, there's an easy way to specify a catch-all at the end of the match expression, and we'll talk about that in just a moment. Let's move on to a quick demo where we demonstrate how conditions can be specified inside an individual case. There are two ways of doing this: pattern guards and ORed expressions. Let's start as usual with a value day of week. This time let's set that value to be Saturday. Let's now go ahead and try and print out a custom message which varies with the day of the week. And we do so here using an ORed expression. Notice how the second and the third case clauses in this particular pattern match use the OR operator to combine patterns into each of the two case clauses. And of course, Saturday matches the highlighted pattern, and the result is lazy weekend. An even greater degree of granularity is possible using pattern guards. The idea is similar to pattern guards with for loops. As you can see here, we have an if expression which tests whether the value to be matched is equal to Saturday. And as a result, the return value of the pattern match as a whole is the string sizzling Saturday. The use of the variable some other day is an example of a value binding. Scala is smart enough to understand that what we would like is to have that variable some other day take on the value of the matched variable day of week. That value binding in the variable some other day is now available for use in the condition in the pattern guard. As we've already seen, if no case clause in our match expression happens to match our pattern, well then a scala.match error results. There are two ways in which to deal with this, both of which involve specifying a catch-all case clause. The first way to do this is using a value binding. The second is to make use of the wildcard operator underscore. Let's jump into a quick demo which shows how each of these two is used. As usual, we have a value called day of week, which here is set to Friday. Next up, we have a match statement. But the interesting thing here is that we match only Monday, Sunday, and then we have a catch-all clause. Clearly, Friday is not going to match either Monday or Sunday, and this is where the value binding comes into play. Notice the variable some other day. Scala will assign the value Friday to this particular binding some other day. It will then go ahead and evaluate the expression on the right hand side of the arrow. It will print out a message to screen and then return that value some other day. This is a value binding in action. A pattern matches against this value binding, and that simply takes the value of the match variable. This is conceptually similar to the default clause inside switch statements in Java or other common languages. There is yet another common way of achieving the same effect, and that makes use of the placeholder variable underscore. We'll have quite a bit more to say about underscore when we talk about functions later on in this course. Instead of having a value binding as we did in the example a moment ago, we can specify the case statement to match just the underscore. Underscore is a way of telling Scala to match anything. In this case, underscore will match the pattern day of week. As before, the expression on the right hand side of the arrow will be evaluated and its return value will be the return value of the entire pattern match. But there is one thing that you need to keep in mind while using the underscore. You cannot use the underscore on the right hand side of the arrow. Notice how, for instance, here in the right hand side expression block, when we need to allude to the original value, we do so using the variable $day of week. We are not using underscore because that is simply not available on the right hand side of the arrow. We can test that this is indeed the case by replacing the return value with the underscore. Instead of returning day of week, we attempt to return just the underscore. And as you can see, the Scala compiler isn't very happy with this. We get an unbound placeholder parameter error message, and so that's just not going to work.